Okay, so how are we going to use concentration? Well, with acids and bases, we can use that to quantify how acidic or how basic something is based off of its concentration. And we call this the pH scale. So the acidity of an aqueous solution depends on the concentration of hydronium ions. And remember, the hydronium ions result from hydrogen ions coming together with a water molecule, creating H3O+. And we learned about that when we talked about acid and base reactions. The pH of a solution is defined as the negative base 10 logarithm of the hydronium ion concentration, as long as that concentration is in units of moles per liter, which we know as molarity. We show concentration in square brackets. So that little square bracket that's around the H3O+, that stands for concentration. So we can define pH as the negative log of the H3O+ concentration. We can also take a pH and solve for the H3O+ concentration by doing the opposite of a base 10 log, which is 10 raised to the negative pH. So in pure water, the H3O+ concentration is 1.0 times 10 to the minus 7 molar. Therefore, we can plug this concentration right in to H3O+ and put that into our calculator to solve for the pH of 7. So what I want you to do is pull out your calculator, because logs are not something that everyone remembers how to do on a calculator, especially if it's a new calculator to you. Okay, you can also try this on your ALEKS as well. Make sure you know how to use this. Okay. If your standalone calculator does not have a log button or a 10 raised to the button, then you'll have to use the ALEKS calculator to do these problems on your homework and the exams. So to solve for pH, we want to do our pH is equal to the negative log of our concentration, and for water that's 1.0 times 10 to the minus 7 molar. So to type this into our calculator, we would do the negative button, and then we would do the log button, and then we would type in our concentration. Let me get our answer. If you have a calculator that is not one of the graphing calculators, and if it's a smaller one, some of them require you to type in the concentration, like type in the number and then hit the log button. Okay, so please try this on your own calculator so that you know how your calculator works specifically, so that you're not lost on your homework or your exams. Okay, so again, you can also try this on the ALEKS calculator. You will always have the ALEKS calculator on your screen, so you can always use that. But on graphing calculators, that's how you plug this in. If it's not a graphing calculator, if it's one of the small calculators, you usually have to type in the concentration and then hit the log button and then remember to change the sign. So keep that in mind. Please practice it on your own calculator. If you do not know how to do it on your calculator, if you're looking at it like, how do I do this? You can either, one, send me an email and show me what calculator you have, and I will tell you how to do it because I've seen it on all calculators. Or go to good old YouTube, search the type of calculator you have, and type in how to do a log function, and I guarantee someone has a YouTube video about it. So please know how to use this on your own calculator. Okay, so for pH, we just type in our -10 to our concentration. If we wanted to know the concentration from the pH, so let's say we knew the pH of water was 7, we would plug that in. So to do that, again, on graphing calculators, you want to do second log button. That gives you a 10 raised to the. This 10 raised to the is different than our scientific notation 10 raised to the. So just keep that in mind. It is different. Okay. I don't want to get into all the differences with base 10s and everything like that on calculators. It's a whole thing. So just hit second log, and that'll give you 10 to the. Then you do negative of your pH. So whatever the pH value is, you just do the negative of that value, and what comes out is your concentration. So we know our concentration at pH of 7 is 1 times 10 to the minus 7 molar. Okay, so we'll practice that. The pH scale is logarithmic, so it's base 10. Okay, so everything is different by a factor of 10. So here on our pH scale, we see what's in red is more acidic, so it has a pH of a really low number. So low pH is acidic. And then we go down to the higher end in the blue. High pH is referred to as basic. So low pH things, acidic things, these are going to be like foods that we eat every day and drinks and everything, because our stomach is acidic. So we ingest more acid-based foods so that it works with our body. And more basic things are going to be like cleaning supplies and other things that, if ingested, could kill you. That's just how I remember it. Things that we ingest should be like our bodies, which is acidic. So basic things, if we ingest them, such as cleaning supplies, they would kill you. So, okay. And you can see that our concentrations relate to our pHs. So something I like to point out is that if you look at the exponent on these concentrations, the positive version of that exponent is your pH. So a good way to check your work is, if you know the concentration and you're trying to find the pH, well, look at your exponent. It should be around that number. Okay, so it's a good way to check your work. So yeah, that's our pH scale. It ranges from 1 to 14, and it ranges by that because of the logarithmic scale. So let's practice that. Let's practice putting these in. Please use your own calculator, like the one you're going to be using on your exams. Don't use your phone's calculator, because you're not using that on your exams. Use the calculator that you are going to be using. If you want to pull up your ALEKS homework right now, just to have the calculator present, go for it and type it in with me. So for these, we want to determine the pH of each solution with the following hydronium ion concentrations. So for these ones, we're going to use this equation. So our pH is going to be equal to the negative log of the concentration given. And again, our little trick, our number for pH should be around 4. So that's what we're looking for, approximately 4 for our pH. So let's plug that into our calculators. On mine, I do a negative log, and then I type in my concentration, 5.3 times 10 to the minus 4. And I get a pH of 3.3 with sig figs, which is near 4. It's within 1 pH unit of 4. So there we go, checking our work. Okay, for your next two, I want you to try those on your own. Please type them into your own calculator so that you know how to use it and you're not at a loss when you go to do your exam. So try these on your own calculator now. The setup for these is the same. pH is just equal to the negative log of that concentration. Again, we should be around 6 and around 12 for each of these, give or take 1. Okay, so we do negative log of 7.1 times 10 to the negative 6. 5.1 for our pH. And then we have negative log of 4.8 times 10 to the minus 12. And that is 11. And I don't think I said this explicitly on our previous slide. It was written, but I don't think I said it in words. So I'll write it up here. pH is dimensionless, which means it is unitless. So it does not have a unit. So these are all unitless. We don't put a unit at the end of them. Okay, so we've solved for the pH from some concentrations. Now let's do the opposite, and let's use this equation where we're given the pH and we want to find the hydronium ion concentration. So we have some pHs here. We want to plug these into our calculator. So I'll do the first one and then you'll solve the rest on your own. So if we want the hydronium ion concentration, what we're going to do is take 10 and raise it to the negative pH. So here it's 5.20. So in my calculator, I do second log, because there's a 10 raised to the, and then I do negative 5.2. Okay, and again, this pH is now going to tell me approximately where my exponent should be in my concentration. So it's going to be around 5. So we have 6.31 times 10 to the minus 6, which is close to 5. Okay, so for these next ones, I want you to try these on your own. Again, typing this into your own calculator that you are going to be using on the homework and the exams so that you are comfortable and prepared to do that independently. So again, this just becomes 10 raised to the negative 16, 10 raised to the negative 11.20, and 10 raised to the negative 2.42. So second log negative 16, we get 1.0 times 10 to the negative 16. I think this should have 2 extra zeros on there for sig figs. Second log negative 11.20. Oops, I did the wrong one, sorry. Second log, there we go. That was an incorrect number. Negative 11.20, there we go. So we get 6.30, let's do 10 for rounding, times 10 to the minus 12. So it should be around 11, 12 is close to 11. So then our last one, log, we do negative 2.42. So we get 0.00380 molar. These should all have units of molarity because we're solving for the concentration. Remember, square brackets mean concentration. We're determining the hydronium ion concentration, so these are all concentrations. Yes, we can get units from this dimensionless quantity because that's how pH works. So we can get these in molarity.